Something extraordinary is happening beneath the surface of Italy, something that could change the world as we know it. The ancient Campi Flegrei supervolcano, which has slept for centuries, is showing alarming signs of awakening. Scientists are on edge, monitoring every tremor, every wisp of gas, every shift in the ground. The question on everyone's mind: is this the calm before a catastrophic storm? What NASA has recently uncovered could be the key to understanding whether we are standing on the brink of an eruption that could alter history forever. The clock is ticking, and the stakes couldn't be higher. The Campi Flegrei supervolcano, located near Naples, Italy, is one of the most formidable geological structures on Earth. Known as the Phlegrean Fields in Latin, this massive caldera has a history of devastating eruptions, with its last major eruption occurring nearly 39,000 years ago. This eruption was so powerful that it is believed to have contributed to the extinction of Neanderthals and drastically altered the climate of the region. Today, the supervolcano lies dormant beneath a densely populated area, but recent data from NASA has reignited concerns about its potential to awaken. The increasing seismic activity and ground deformation observed in recent years have led scientists to issue warnings about the possibility of an eruption. This has put the global scientific community on high alert, as the eruption of Campi Flegrei could have catastrophic consequences not only for Italy, but for the entire world. Understanding the significance of this supervolcano and the implications of its reawakening is crucial as humanity grapples with the potential threat of one of nature's most destructive forces. The Campi Flegrei supervolcano has a long and tumultuous history that dates back over 200,000 years. Situated in a region with a rich geological past, this caldera has been the site of multiple eruptions, each leaving a profound impact on the landscape and climate. The most significant eruption, known as the Campanian ignimbrite, occurred approximately 39,000 years ago and was one of the largest volcanic events in the last 100,000 years. This eruption spewed vast amounts of ash and gases into the atmosphere, creating a volcanic winter that likely played a role in the decline of Neanderthal populations across Europe. The eruption also led to the formation of the caldera, a massive depression that spans about 13 kilometers across. Since then, Campi Flegrei has experienced several smaller eruptions, with the most recent occurring in 1538, creating the Monte Nuovo Hill. The area remains geologically active, with frequent ground uplift and seismic activity, signaling that the supervolcano is far from dormant. Understanding this historical context is essential for grasping the potential danger posed by any future eruption, as past events offer crucial insights into what might lie ahead. Recently, NASA's advanced satellite monitoring systems and ground-based sensors have detected troubling signs beneath the Campi Flegrei supervolcano. These observations include unusual seismic activity, increased gas emissions, and significant ground deformation, all indicating that the caldera is experiencing heightened levels of unrest. NASA's discovery is particularly alarming because it suggests that the magma chamber beneath Campi Flegrei may be reactivating after centuries of relative quiet. The ground in the area has been rising at an accelerated rate, a phenomenon known as bradyseism, which indicates the potential accumulation of magma or the movement of volcanic fluids beneath the surface. This uplift, coupled with frequent small earthquakes, points to increased pressure within the magma chamber. Moreover, NASA's data has revealed that the temperatures beneath the surface are rising, further intensifying concerns about a possible eruption. The presence of gases such as sulfur dioxide, which have been detected in increasing quantities, also suggests that magma is moving closer to the Earth's surface. These findings have led NASA and other scientific agencies to raise the alert level for Campi Flegrei, emphasizing the need for close monitoring and preparedness in case of an eruption. The signs indicating that Campi Flegrei may be on the brink of an eruption are becoming increasingly difficult to ignore. One of the most significant indicators is the phenomenon of bradyseism, where the ground in the region has been steadily rising due to the accumulation of magma or volcanic gases beneath the surface. This ground uplift has been accompanied by a series of low-magnitude earthquakes, known as volcanic tremors, which are often a precursor to larger seismic events and potential eruptions. These tremors suggest that pressure within the magma chamber is increasing, potentially leading to a breach. In addition to seismic activity, scientists have observed an increase in the emission of volcanic gases such as carbon dioxide and sulfur dioxide. The rising levels of these gases are a clear indication that magma is moving upward, pushing gases through cracks in the Earth's crust. Another critical sign is the increase in surface temperatures in and around the caldera, detected by satellite imaging and ground-based thermal sensors. This temperature rise, combined with the other signs, suggests that the supervolcano is entering a phase of heightened activity, raising the possibility of an eruption in the near future. An eruption of the Campi Flegrei supervolcano could have catastrophic consequences, not just for the immediate region, but for the entire world. Given its size and the potential scale of an eruption, the effects would likely be far-reaching and devastating. Locally, the eruption could lead to massive pyroclastic flows, fast-moving currents of hot gas and volcanic matter that would obliterate everything in their path, including the densely populated areas of Naples and surrounding towns. The ashfall could cover vast regions, causing buildings to collapse, contaminating water supplies, and making large areas uninhabitable. Globally, the eruption could eject vast amounts of ash and sulfur dioxide into the atmosphere, leading to a significant cooling of the Earth's climate known as a volcanic winter. This would result in crop failures, food shortages, and economic turmoil as the global agricultural system struggles to cope with the sudden drop in temperatures. The disruption to air travel would also be severe, with ash clouds grounding flights across Europe and beyond. Additionally, the release of sulfur dioxide could lead to acid rain, further damaging ecosystems and agricultural lands. The combined effects would likely trigger a global humanitarian crisis, highlighting the profound impact that a single supervolcanic eruption could have on the world. Campi Flegrei is classified as a supervolcano, a type of volcano capable of producing an eruption with ejecta exceeding 1,000 cubic kilometers, which is thousands of times more powerful than typical volcanic eruptions. The science behind this immense potential lies in the structure of the caldera and the magma chamber beneath it. Unlike a typical volcano, where magma builds up in a central vent, a supervolcano has a vast magma chamber that spreads out over a large area. In the case of Campi Flegrei, this magma chamber stretches beneath the Phlegreian fields, a region known for its complex network of fractures and faults. The caldera was formed during a series of catastrophic eruptions, the most notable being the Campanian ignimbrite eruption about 39,000 years ago. Since then, the magma chamber has been slowly refilling, with magma composition evolving over time. Scientists study the supervolcano by monitoring seismic activity, gas emissions, ground deformation, and temperature variations, all of which provide clues about the state of the magma chamber. Understanding the interplay of these factors is crucial for predicting future eruptions. The supervolcano's unique geology, combined with its potential for massive eruptions, makes it one of the most closely watched volcanic systems in the world. Scientists continue to study the physical and chemical properties of the magma, the dynamics of the caldera, and the processes that might trigger an eruption, aiming to improve prediction models and mitigate the risks associated with such a powerful natural force. The potential eruption of the Campi Flegrei supervolcano has prompted local, national, and international authorities to develop comprehensive emergency preparedness plans to mitigate the impact on human life and infrastructure. Given the densely populated regions surrounding the caldera, including the city of Naples, the stakes are incredibly high. Emergency preparedness involves multiple layers of planning, starting with real-time monitoring of seismic activity, ground deformation, and gas emissions. Scientists and government agencies work closely together to analyze data from these monitoring systems. enabling them to provide timely warnings if the situation escalates. Evacuation plans are a critical component of emergency preparedness. Authorities have mapped out evacuation routes and designated safe zones far from the caldera where residents can seek refuge. Drills are regularly conducted to ensure that both the public and emergency services are familiar with these procedures. Public awareness campaigns are also essential, educating residents about the risks and the steps they should take in the event of an eruption. Communication strategies are in place to disseminate information quickly through various channels, including social media, radio, and emergency alert systems. On a broader scale, international collaboration is key as the effects of a supervolcanic eruption would be felt globally. Countries around the world are involved in sharing data, resources, and expertise to enhance the overall preparedness. The goal is to minimize loss of life, manage the humanitarian response effectively, and ensure that recovery efforts can begin as soon as possible in the aftermath of an eruption.